Hey guys, so I'm sure you've heard from your other AP classes that College Board has decided to cut off our instruction when we hit 75% of the material. Unfortunately, we are not there yet, so I think this is probably going to be the best way to keep going until we can hit that mark of how much they're going to test. From what I've heard, it's going to be a at-home 45-minute test, so that's really good for you guys. They should be sending out more details today, and as they send out details to me, I'll try and forward them to y'all so that y'all can see what's going on as well. But we do have a few more chapters we have to get through to hit that 75% mark, and I just thought this would probably be the easiest way to accomplish that. That way you can watch them at home and get the notes and do a little bit of the work that goes along with it. As you're watching these, feel free to pause at any time so that you can write down. I'm not going to be giving you the time like I would in class, but you can always pause the video. If you have any questions about anything, please email me, and I definitely recommend doing the problems along with me, just like you would in class. So if you don't have your calculator sitting beside you right now, go ahead and pause the video and go grab that, or go ahead and grab some pencil and paper. That way you can take notes. So this is chapter 18. It is on sampling distributions for sample proportions and sample means. What are sampling distributions? So we've already know this, that there's a whole population. Usually the population is too big for us to get all the information. So we take a sample. From the sample, we collect statistics, and then we use those statistics to predict information about the population. The official vocab word for that is statistical inference. So we're just looking at the relationship between samples and the population, and we're looking at different sampling distributions. And we are going to use the normal curve to calculate any questions that they may ask. So the first one is sample proportion. So make sure you know the difference. We're going to talk about sample proportions today and sample means. They are not the same thing. So make sure you write down these are sample proportions. You always have to do a simple random sample of size n from a large population, and it's going to have proportion P. The sampling distribution of the sample proportion is going to be approximately normal. And so the way you find your mean and standard deviation when you have a sample proportion, like I said, sample means is going to be different, so make sure you know the difference. The mean is just whatever your proportion is, and the standard deviation is the square root of your proportion times, remember, 1 minus your proportion. So let's just say your proportion was 40, like 40%. Q would be 60%. They need to add up to 100. Divided by n, that's your sample size. So we're going to do an example real quick. It says, based on past experience, a bank believes that 7% of the people who receive loans will not make payments on time. The bank has recently approved 200 loans. What are the mean and standard deviation of the proportion of clients in this group who may not make payments? So you do always want to draw your normal curve. You're going to label your 3 standard deviations. So from this, the mean is the proportion. That's going to be 7%. To get standard deviation, this is where you do that square root of P times Q over N. So if 7% are likely to not pay loans on time, so that means 93% is likely to pay loans on time, and we did 200 clients. So that makes a standard deviation of 1.8%. So you would label that on your bell curve. Now, it's asking us to find the probability that over 10% of these clients will not make timely payments. So we expect about 7, but what's the probability that it's going to be more than 7, that it's going to be 10%? I always recommend finding the z-score when doing this. Remember, z-score formula is x minus mean over standard deviation. So we're looking at 10 minus 7 over your standard deviation. And then we're always going to use normal CDF when we're looking for situations like this. And normal CDF, so if I wanted more than 10%, that means my lower bound is that z-score of 1.667, upper bound 99. Anytime you use z-score in normal CDF, remember your mean is 0 and standard deviation 1. Now, I have showed you guys that you are able to use the actual values from the problem to do the same thing, and I'm totally cool if you do that. But make sure that you label your upper bound or lower bound, upper bound, mean, and standard deviation when you write normal CDF on your free response paper. Oops. So another example, same thing. Public health statistics indicate that 26.4% of American adults smoke cigarettes. Using the normal model, draw the sampling distribution model for the proportion of smokers among a randomly selected group of 50. So we're doing the exact same thing. Mean is pulled right out of the problem, 26.4. Standard deviation, we're doing that square root of PQ over N again. and then we would label the curve. You also want to find your z-score, x minus mean over standard deviation, and then we're still going to put this in normal CDF. So like I said, I want you doing this along with the video, so make sure you're able to get these out of the calculator on your own, even if that means you pause the video to check to make sure you can still do it. Oops, went too far. So these are super, super, super important for Unit 5. You absolutely 100% have to memorize the conditions and assumptions. In Chapter 18, we're just kind of like noting that they're here, but they are about to really, really, really come in handy, so you've got to memorize these. Whenever you are checking for a sample proportion, these are the things you have to check. It must be independent and random. So whatever's happening, those samples must be independent of one another, and you must have gathered them randomly. This is a requirement. The population must be 10 times the sample size. So whatever you're observing, there must be at least 10 times more of that in existence. And then NP, which is your sample times the probability of success, and NQ, probability of failure, must be at least 10. This has to happen every single time. Please make sure you write these conditions down because they are going to show up over and over and over and over again in the next couple chapters. Oops, before we get to that, I actually want to show you how these work in this previous example. So showing that they're independent and random. So we are gathering American adults who smoke cigarettes. So we want to make sure that one adult is independent of another. For instance, you wouldn't want a mother and her child, okay? Because obviously if you grow up in a home that's smoking, if your mom's in the sample, you're likely to be in the sample too. So independent would mean they did not come from the same family. Random means we randomly chose people. We understand that. Your population must be 10 times greater. So we sampled 50 adults. There are more than 500 adults who smoke. So that meets that requirement. So you would take 50, which was our sample size, times 10, make sure there's more than that in the existence. There are more than 500 adults who smoke. And then N times P would be 50 times 26.4. So we want to make sure that we have more adults who smoke than that when we do it. 50 times 0.264 gives me 13.2. So I need to make sure that more than 13.2 people in the sample smoke. We do have that. And then the other way would be 50 times 0.736. Gives me 36.8. I need at least 36.8 who don't smoke. So make sure that that is a thing. Okay, you absolutely 100% have to be able to do these conditions here. All right, next is sample means. So we just finished sample proportions. These are sample means. They are not the same. Sample means still come from a simple random sample, size n, that hasn't changed. Your mean is still whatever is in your problem, but your standard deviation is a little bit different. This time you are going to do your population standard deviation over square root of n to get your sample standard deviation. Okay, so sample standard deviation is the one you're using with your problem. Population standard deviation is the one that deals with the entire population. This is why there's two of them in your calculator, by the way. You have SX and then you have sigma x. Sigma x is your population standard deviation. SX is your sample standard deviation. So make sure you have these two down, that you know how to get mean and standard deviation from a sample mean. So in our example, it says, assume that the distribution of human pregnancies can be described by a normal model with a mean of 266 days and a standard deviation of 16 days. Draw the normal model. We're going to find the mean length of pregnancies among a sample of 60 pregnant women in the office. And then we're going to find the probability that a mean duration of these pregnancies will be less than 260 days. So again, your mean matches what's in the problem. This is the same for sample mean and sample proportion. Your standard deviation, you have to use the formula. The standard deviation in the problem was 16 over our sample size of 60 women. So we do 16 divided by square root of 60. That makes our standard deviation 2.07. We're going to label the bell curve. Now, in order to find the probability, we're going to do it with z-score, but like I said, you can always do it not using z-score, using the actual values. Z-score is x minus mean over standard deviation. And so because I want less than 260 days, I would do from negative 99 to my z-score. And then in this situation, the mean was 0, standard deviation 1. If you use your values, you will get the exact same answer. That is fine. Just label them. And the conditions for sample means are very similar to sample proportions. There is one difference. They still must be independent and random. That has not changed. So in the pregnancy problem, we needed to make sure that the women were independent of one another and that they were gathered randomly. Population must be 10 times the sample size. There were 60 women in that problem. 60 times 10. I'm sure there's more than 600 pregnant women on this planet. The one that is different is your sample size N should be large. We generally go with the rule of 40. So we want our sample to be greater than 40. This is where it's different than sample proportions. Make sure you write these 3 down. These are going to come back over and over and over again. So we want to make sure we sampled at least 40, and we sampled 60, so we are good to go here. So I want you to try these examples on your own, meaning I want you to pause this video right now and try these and then hit play and you will get to hear the answers. For this problem, it says it is generally believed that 34% of all high school students have an STD. Find the mean and standard deviation from a sample proportion of size 100. This is how you know if you're dealing with a sample proportion or a sample mean. If the problem talks about proportions, you're using sample proportion. If the problem talks about means, you're using sample means because you got to know which formula to use. Mean doesn't matter. In this case, it is still 0.34. That has not changed. And your standard deviation for this problem, you should have gotten 0.047. The second piece says, if you collect a random sample of 100 students at your high school, find the probability that more than 1/3 of them will have an STD. So if I want more than 1/3, that means I had to do, the lower bound would have been 0.33, upper bound would have been the 999 with 0.34 and 0.047. So I got 0.5842, will be more than 1/3. So make sure you got the same answers. Again, for this example, pause the video and try it real quick on your own, and then hit play and listen to me give you the answers. This problem says, assume the distribution of the time students spend doing homework each night can be described by a normal model, mean of 2.7 hours and standard deviation of 0.76. Find the mean and standard deviation of the sample. So mean is, again, from the problem, 2.7, and the standard deviation you should have got would have been 0.062. Then it asks, what is the probability that the mean number of hours doing homework will be less than 2.5? So when you put that into normal CDF, I got 0.0063. So check and make sure your answers are there. I am still going to post the classwork onto Google Classroom so that you can try it out there. I will also post answers so that you can see. Haven't quite decided how we're going to go about getting in grades for actual completion yet. We're going to work on that. Not just completion. Completion's easy. Getting grades in for quizzes and things like that. So working on that. But for now, just make sure you're knocking out classwork. I will try and do at least a few of these per week. That way we can catch up and have you ready in time for the exam. I will be posting the information from College Board as they send it to me. So be looking out for that as well. Hope you guys are doing good. And I will see you guys later.